We started on the last video we did variables on both sides. So today we're going to do a little more with that. It's the same notes paper you have that we did those two examples on. We're going to start with number 3, and we're going to kind of combine all of the things we've done so far. So, guys, I personally like to just scribble out that problem number, that number 3, so I don't get confused and think it's part of the problem. So let's draw our line and let's combine all the things we've done. Are there like terms on the left? No, there are not. So we can't do anything. Let's write it down. Are there like terms on the right? Yes, there are. C's. This is a minus. So 7C minus 2C is 5C. And please remember that minus is attached to the 14. Now, this is what we did the day before. We did the simple variables on both sides. So I recommend that the first thing you do is take away one of the variables. I know most of you like to take away the one on the right, so let's do minus 5C. We get 3C plus 1 equals negative 14. Now you have a basic two-step equation that you know how to work. So 3C equals negative 15. I'm going to go through this pretty quickly because this part we should be really good at. C is negative 5. I'm not going to check it for now, guys. I'm going to do number 4. I'm going to scribble this out so it doesn't confuse me. Now, the first thing you always have to take care of is parentheses. You have to figure out what is multiplied by the parentheses. Well, it's the negative 7. The 5 has nothing to do with the parentheses, so we bring it down. Negative 7 times t. I wish I had not used a t here. I wish I'd used an x. Is negative 7t. Negative 7 times 1 is negative 7. Remember that the negative becomes your minus. Please don't put minus negative. Some of you are doing that and confusing yourselves. Bring down the negative 10t plus 4 because there's nothing we can do. On this side, I can combine the constants, 5 minus 7, and get negative 2. Bring down the negative 7t. Bring all of this down. Now I have what I did on the maze when I had a variable and a constant on both sides. I would like to get rid of a variable. I'm going to get rid of the one on the right. It's negative. The way you get rid of it is do the opposite. So let's add 3t minus 2 equals 4. Now I have a really basic two-step. Add 2, 3t equals 6. Divide by 3, and t equals 2. I'm not going to check it right now in the video, but you can check it and see that that is correct, that t is 2. So let's move on to number 5. And 2 is multiplied through the parentheses. So we don't multiply the 5, we just bring it down. 2 times k is 2k, 2 times 4 is 8. Now we're multiplying 5 through the parentheses. 5 times k is 5k. 5 times negative 3 is negative 15. Please don't put minus negative. Just put minus 15. Bring down your plus 10. On the left, we can combine our constants, so we get 2k plus 13. On the right, we can combine our constants, 5k minus 5. It looks a lot simpler once you take care of the parentheses and combine like terms on the same side. We can't combine across an equal sign. We have to do the opposite. So let's minus 5k. We get negative 3k plus 13 equals negative 5. Don't drop that minus. Some of you are dropping the minus. The minus becomes your negative. Bring it down as negative 5. Now let's subtract the 13. Negative 3k equals negative 18. Let's divide by a negative 3. And k equals 6. Please use your calculators if you're confused about your negatives. You don't want to miss the problem because you missed a negative. Now let's look at number 6. 2 gets distributed. 2x plus 6 is less than 2x plus 6. This looks a little strange. Let's see what happens if we subtract the 2x. Both of them go away and we get 6 is less than 6. Well, that's not true. When the letters all go away, you have a special case. This is a special case. 6 is not less than 6. It's not true, so our answer is no solution. That means there is no value of x that would make this true. It doesn't have a solution. But let me show you the other special case. What if that had been an equal sign? That is true. I still have no letters. The letters went away, but 6 does equal 6. That's true. That means that any number I put in for x would make that a true statement. I can't even count how many solutions are. There are infinitely many. Any number, any fraction, decimal, negative, positive, any number I can think of would make it true. So we have infinitely many solutions. You also might see this as a big funky looking R. That means all real numbers. That's another possibility you might see for this special case. There are imaginary numbers in math, but you will not learn them until Algebra 2. So that's why we say all real numbers. Okay, one last example. Perimeter. Perimeter measures the distance around an object. Perimeter is found by adding all the sides. You learned that in 3rd grade, and it's still true. It didn't go away. I want you to draw the picture. The reason I want you to draw the picture is I want you to label your length and your width, because I want you to remember that a rectangle has 4 sides. Those aren't the only 2 sides. If you didn't draw the picture, you might just add these 2 and forget that the rectangle has 2 more. So let's label this one and this one. By definition of a rectangle, we know those are the same. But the perimeter is 98. How do I get the perimeter? I add all the sides. X plus 3 plus x plus x plus 3. And we know that's going to be 98. Combine your like terms. How many x's are there? 1, 2, 3, 4. 4 x's. 3 plus 3 is 6. Now I have a simple 2-step problem. If you solve that, you're going to get that x is 23. Well, isn't x our width? And didn't the problem ask me to find the length and the width? The width is 23 inches. The length is x plus 3. So whatever x is, add 3 and get 26 inches.